So this is like, I would say, part two of the integration by part, where you have these multiple time integrals, or you have some hidden second factor which you have to take it as u or v dash. So these three are the interesting examples. Similar questions and have been assessed in exams so far. So let us just first try to find out how to do the first question. So first question is x squared sine x. I'll just rewrite the formula that we have, which is uh, integration of uv dash is uv minus integration of vu dash dx. So uv minus integration of vu dash dx. So out of this x squared sine x, if I take isolate, a comes first and t is later on, which is trig. So u is x squared and v dash is sine x. So u dash is going to be 2x, v is going to be cos x because I need in the formula. So when I integrate, it'll be x squared sine x and equals to uv, which is x squared. Sorry, this is going to be negative cos x. So x squared negative cos x and minus integration of negative cos x times 2x. So as a result of this, you'll notice that it is negative x squared cos x plus 2 you can take outside times x cos x dx. Now the problem here is that you see again you got x cos x as an integral to be done. So now once again you'll have to apply integration part. So what I'm going to do is separately integrate it, which is integration of x cos x. Now once again u is going to be x, v dash is cos x. So u dash will be 1, v will be sine x. So integration of this will be uv, which is x sine x, minus integration of cos x. I mean integration of sine x times derivative of, u dash will be 1. This is u. So u dash is going to be 1. So if I integrate this once again, it will be x sine x, and integration of sine x is negative cos x, will become positive cos x because of the outside minus. So what I'm going to do next is you're going to put this value out here. So your final answer as a result of this will be negative x squared cos x plus 2 times x sine x plus cos x and plus c. So that's what is the integral like where you have to apply integration by parts twice. So the next example that I've put a little harder category is integration of ln x. Now here it seems like we don't have any straightforward formula for integrating this, but what we have is if I can just write down this as 1 times ln x, and then you can apply integration by parts here. So if I have 1 times ln x, I can take it as 1 is algebraic function and ln x is the log functions. So if I do isolate, so let's say, so a comes later, so my u becomes ln x and v dash is 1. V dash is 1. So now in the formula, when you do uv dash integral is uv minus integration of v u dash. So u dash is going to be 1 over x and v is going to be integration of 1 is x itself. So now I put in the formula uv, which is u times v, so it'll be x ln x minus v, which is x, and u dash is 1 upon x. X and x cancel, so you get x ln x minus integration of 1 dx, which is x ln x minus x. Integration of 1 is x and plus c. So this is the integration of ln x. Very important result, asked several times in the exams. So the third type that troubles the students most is, let's say, something like this: e to the power x sine x. Now, in this case, when I do, let's say, isolate or liat, whatever you want to do, trig is here and exponential is here. So exponent comes after trig. It means my u is sine x and v dash is e to the power x. So in my formulas, you'll need u dash is negative cos x. I mean, derivative of sine x is cos x. And v will be integration of e raised to x. So integration of x e raised to x is e raised to x itself. So now you plug in the formula, which is uv dash dx is uv minus integration of u dash dx. So first is uv, which is sine x times e to the power x minus integration of uv, u dash. So sine x is v, I mean e raised to x is v. So e raised to x times, I just rewrite this. So e raised to x is v times derivative of sine x, which is cos x. Now, once again, we are back to the basic. We got integration of e raised to x cos x, which cannot be integrated further without, like, once again doing by parts. So what we do is we integrate once again this part. Okay, so if I integrate e raised to x cos x, once again apply the same way. So u will be, let's say, cos x. So u is cos x and v dash is e to the power x. So u dash is going to be negative sine x and v is going to be e to the power x. So when I integrate this, it'll be uv, which is e raised to x cos x minus integration of uv dash, I mean vu dash. So e raised to x times negative sine x. And if you open this bracket, you get e raised to x cos x and plus integration of e raised to x sine x dx. Now, once again, we got the same integral from where we started, but at this time, we can make use of very interesting fact here is that this integral is equivalent to this. So we're going to put it here. So it'll be sine x times e to the power x minus integration of e to the power x cos x. So e to the power x cos x will be this entire integral, which will be, I can just get rid of this integration sign, put out here the value. So e raised to x times cos x plus integration e raised to x sine x, where we had started from. But don't worry, because my left hand side is also e to the power x sine x. We'll make use of this concept now. So it'll be sine x, e raised to x sine x minus e raised to x cos x minus, if you open the bracket, this will become negative e raised to x sine x dx. Now, we can keep doing this and you'll keep getting the same integral again and again. So rather than this, what I can do is I can transfer this thing here smartly. It becomes e raised to x sine x plus, I mean dx, plus e raised to x sine x dx equals to e raised to x cos x, e raised to x sine x here, which is minus e raised to x cos x. Now I'm just writing this thing here. If I integrate the same thing twice, it'll be 2 times the integral of e raised to x sine x is e raised to x sine x minus, you can put a constant anywhere if you want, or we can put at the end, sine x minus cos x, and plus, like, we'll put the constant towards the end. So integration of e raised to x sine x will be e raised to x over 2 sine x minus cos x, and you can put a constant c towards the end. So this is how you do the integration of e raised to x sine x, which has been assessed at least like multiple times in the exams.